Today I'm going to talk about this ESP-12 programming jig that I hacked together. So the idea is basically I want to start using these individual chips a little more, these chips, instead of something like that which has all the components on it. And these chips, the spacing, they're not breadboard friendly. So it's to basically program this. Before I would solder wires directly to this. It's time consuming, it's ugly because then you have solder all over the place, and I wanted a quick way to be able to prototype these, test them, and this kind of jig allows me to do that. So the concept of it is these two halves, I'll show you in a minute when I try to run a demo through, but these two halves slide together. So the chip sits in the middle on this little ledge, and this one, these little pogo pins push together on these pins to make a solid connection, but not a permanent connection. So pogo pins here. Pogo pins are these metal pins here that are spring-loaded. So when you push them, they will basically force themselves in the holes of the ESP module to make a good contact. So all these pins around the side, there's 4 on each side of the board. So that makes all of the 16 pins that I care about. I don't do any of the top pins because I don't need to touch any of those. And then also on the board, there's 2 buttons. There's one on the top, one on the side. I'll talk about those in a minute. There's various resistors that are soldered directly onto the jig, and 2 capacitors as well to keep the power stable. In the program, that's all I need is basically this little FTDI serial programmer, 4 wires, power ground, and the 2 serial connections RX and TX. That's all that's needed. So to get to this point, it took a lot of different iterations. I'll kind of walk you through my process of how I do things in case it's interesting. So this is a first version right here. What it basically is I want to see if I could fit this chip in this slot. So since the tolerances on a 3D printer are not always perfect, I can measure this exactly, but then when I go to print it, it doesn't work that well. So I have to find that tolerance. So this is the first iteration I tried. Then I printed another one, and that didn't fit. I'm like, why am I doing one at a time? Why don't I try 3 different slots? So I printed out 3 different slots. So I found one that worked, but then it wasn't wide enough. And I keep kind of doing these different iterations until I find one that works. Then this is the next version of this prototype, I believe. Yep. And then so you can see it snaps in and fits into that slot now. And then I was trying to figure out how I was actually going to get the different holes for the pogo pins. So you can see some different hole sizes on both sides that I would play around with the different pogo pins to see what works. And you know, this iteration after iteration after iteration. This one has some pogo pins in it that I was testing. Pull it out and show you actually how it works now. So this is the pogo pin, and if it goes in there, it's just spring-loaded and makes great contact with that. So here's a different version. This one actually I broke. This was, I think, this close to the second to last version. What I figured out is, here is one that I hacked together to try out, and you can notice that this chip is actually stuck in there now. So my mistake was, I can cut it out obviously, but I soldered these wires in this side panel. That's why I left this open, so I could actually make contact with it. And this version, actually, this thing slid in and was supposed to push the pogo pins against it, and you could take it out, so these would basically come out and you could pull the chip out. But it didn't work that way when I soldered this, so I needed a different way to do it. And also, getting these pins in here, since this is such a tight space, was very difficult. So this version didn't work. This was basically the second to last version of this. And then here is what I did is I printed it out again, but I broke it with the concept, and I also removed that panel, that I could connect the wires on the back and then somehow push these together when the chip was in there, and that's kind of what this version does. Here's another version. It's got some more pogo pins in it. Here's another version. And before these versions existed, there were these prototypes, which I tried to do a top-down approach. So the chip would sit on the pogo pins, and we have this baby. So then this one was created so effectively you line up the chip with these pins like so, and you can see like they're squishy, so they make contact, and then this piece would fit on top and snap in here and hold the pin down. This worked, but it didn't work great, and I think I like this one, this version. I might have to kind of circle back around and try this because this fits in a breadboard. I made those headers there so it fits in a breadboard, so you can basically just plug it in and all the pins were exposed. But these pins are so close together, they're 2 millimeters apart, that it's very difficult to get solder in there, and you can see like these were coming loose because they're rubbing up against each other. I tried to heat shrink them, and I was constantly trying to debug what wasn't working on this one. So that's why I switched to a different version where the pins were spaced out further. So that's why they're alternating here, so that they have more room to actually connect on. So this is the process. This was probably over a series of 2 nights that I went through different versions of printing and experimenting and trying to figure out what was working till I got this version. And this is the final version. It's ugly, but it works. So to program it, here's a simple blink sketch, and what I can do is I can just hit programming. I also need to figure out why these sketches are taking so long to program in the IDE. Different problem. But once it gets to the uploading step is when I'll reset this device. You can do it preemptively too, so I could reset it now and put it to programming mode. Which one I'll do that? So to put it in programming mode, you hold down this top button, the yellow button, it says uploading, and you press the reset button on the side. And that should now put it into programming mode, and you can see that it is now actually programming the device. See all the lights flashing? So it's basically just programming the same sketch I had on there. So when it's done, it'll reboot and it should blink. I think 1 second is what I had it to be. Yep. This pin is a reset pin. This one shorts out reset to ground. This one is tied to GPIO 0, which when you hold it will put it on GPI or to ground as well, and that will actually put the chip into programming mode. So you hold that down, reset it. When the chip boots, it's now in programming mode, and you can program it to whatever you want. So now Blink Sketch is running. Programming worked fine. Everything works as expected. So to experiment, to show you with the jig, let's go ahead and shut the USB power off so I don't short anything out accidentally. And this just pulls apart like this. And it's connected by these 2 wires, which is just power and ground. You can see it's just kind of off by itself. You got the buttons on one side, and the only thing that connects is the power and ground. And you can go ahead and wiggle to pull the chip out, empty chip, and we'll put this other chip in that I just pulled out of the bag, fresh. It shouldn't have anything on it. And I just kind of slide it in that slot and push it down. You can hear that very satisfying clicks. And what that basically is those pins falling into the little holes, the pogo pins falling into the holes of the chip, and pressing against it. Then you just take this other half and you slide it in there. And what I like to do is I like to just give it kind of a visual check to make sure it's actually lined up correctly. And all the pins, there's not any bent. Most of the time it's not. So that's like that. Let's go ahead and power back on. It's probably not going to do anything because it's not programmed to do anything. But we can try to add our Blink Sketch back on. Let's try to upload it and see what happens. I put it into programming mode just now. I don't know if you saw that real quick. So it shouldn't need to be thrown into programming mode, but I like to watch it anyways. And usually I can tell by these 2 LEDs here on the programmer. They'll blink really quick, and if they both blink, it's a good indication that it's going to work. If only the TX is blinking as it's trying to send out data to it and it's not receiving it back, that's not a good sign. So you can see they both started blinking, and now the programming jig is actually blinking the ESP module, indicating that it is in fact programming. The programming is very slow. I also need to investigate that. I just need to change the speed, I think. But Arduino is programming this brand new ESP module. You saw me put it in. That took maybe 10 seconds. And now it's done and it's blinking. So that's it. ESP module has been programmed successfully. And I can sit here and go through all these and program them one after another. Slide the jig out, put the chip in, hit the programming button, good to go. But the thing that's going to take the most time is actually the compiling and the physical uploading, not switching out the chips. So, love the jig so far. I have a lot of ideas and plans for how I'm going to use these chips, so this will just make it much easier. I might, in fact, have to make another one of these. I don't have a camera to show, but on the side of my desk, I have about 3 of these different setups, all hacked together with different variations on breadboards. So I'm imagining I'm not going to want to, even though it's easy, I'm not going to want to swap out these chips from these little gadgets. And this thing probably, I would say, cost, I don't know, $2, if that, to make. Materials are marginal, the 3D printing, assuming I don't count the waste. The pogo pins, I bought a pack of 100 on AliExpress, probably for a couple bucks, and then there's a few passive components and buttons. So the jig itself was pretty easy. Time consuming, have to solder all those connections and test it, but once it's up, it's up. So that's my programming jig. I'm excited. You'll probably see it in some upcoming videos, and I will try to post as much information as I can in the description in case you want to build your own.